Welcome everyone to this GSMA IoT WebTalk. Today we will explore the topic of the remote drone identification and how mobile connectivity can be utilized to this effort. My name is Barbara Pareglio and I lead the Connectivity for Aviation and Drone project within GSMA. Before we start, I would like to inform you that you will be able to send all your questions throughout the whole session by clicking on the icon Q&A on the right-hand side of the screen. We will do our best to answer all your questions during the panel session today or after the event. We will also prepare two polls. One is already live and you can provide your answer by clicking the poll icon again on the right-hand side of your screen. You will be informed when the second poll will start. The on-demand recording and slides will be made available soon on our website and you will be receiving an email notification. And now, let's walk through the agenda for this IoT WebTalk. The first 20 minutes, we will explore the remote identification regulation from the perspective of the United States and Europe, which are amongst the first to become available. And we will welcome speakers from the FAA and the EASA. Then we will explore the mobile connectivity, how can it be utilized to remote identification, and how also much more than that. Again, we will welcome the perspective from Skyward from the United States and from Vodafone from Europe. To conclude, we will have a panel session with all our speakers to answer your questions. As a result of this IoT WebTalk, I would like you to have a better idea of what remote identification for drone entails and its importance. I would also like you to walk away and have a better understanding of the overview of cellular connectivity with other services, how it can be utilized, and what it offers. Before continuing, I would like to set the scene and ask you to think about type of identification that you use today for vehicles or smart objects. With these slides, I wanted to use three examples, which I hope we are all familiar with. The first one is also put in order, chronological order. The first one is the number plate or the license plate, which we all used to. The second one is more from the aviation, so we have the registration and identification of the aircraft. And the third one is smartphones, where we all use. They also have an identifier, which is an AMI. So these are our three examples to understand how it works, the identification. When we talk about identification, it's just more than a number. So the number is purely the information that is visible for the human being to be able to process the data. But there is much more attached to identification, and also to understand it is important what it's used for. Another aspect that I would like to bring to your attention is that when they designed the registration for the cars and for the aircraft, I think the system was designed by having in mind a person on board, which of course is not the case of the drones. And maybe perhaps the situation is much closer to what we use in cellular networks. So it is something that we're going to explore during the session. Now you might think, why GSMA is interested in this topic? Why did we look at remote identification for drones? Well, mobile networks have been widely available and dependable, and today they already connect 8 million or more than 8 billion SIM globally. They offer a variety of services, and they also provide the opportunity to enable the beyond visual line of sight operation at low altitude. As an association that represents the mobile industry, the GSMA started to explore this area about 5 years ago and created a drone interest group, which holds more than 50 members as today. And they gather and combine the efforts to understand the needs from the drone operators and from the wider ecosystem stakeholder. So again, I would like to remind you that you have the polls, so please provide the inputs to your polls. And in the next 20 minutes, the poll will be still open. We will open the next poll later on. Now, without further ado, I would like to introduce you to our first speaker, Jay Merkel, the Executive Director for Unmanned Aircraft System Integration Office at the Federal Aviation Administration. Jay has an extensive experience in the aviation industry, and today will provide an overview what the remote identification is, and an importance on how the FAA envisioned the future of regulation for the unmanned system Please, Jay, over to you.
Thank you, Barbara, and good morning from the United States. Next slide, please. So I wanted to start with what are the basic principles that we believe we're putting in place with remote identification. The first is that every drone will broadcast a signal that includes the UAS's identification, essentially, as Barbara said, the license plate, and the operator location. I like the fact that you pointed out, Barbara, that those registration systems for cars and airplanes assumed that the operator was inside the vehicle, so you didn't have to provide that additional information. But with remote identification and with the operation of unmanned aircraft systems, you really do need to add that additional information. We will also make key information available through the internet for every operation, things such as the location of the operation, location of takeoff, et cetera, et cetera. Then authorized individuals such as public safety officials or aviation safety inspectors will have the ability to correlate the UAS ID with the registration information and then be able to identify who the particular owner is. So notice the personally identifiable information will not be made available to the general public. Much like the fact that as you see a car go by in the street, you can write down that license tag, but you don't actually know who's operating it. We want to make compliance as easy and non-compliance stand out very clearly. We in the FAA have a compliance policy. We would prefer to get people to comply than have to go into enforcement actions. So we really do want to make this as easy as possible. And also, to make the rule affordable, we will rely on third-party UAS service suppliers to build and operate any network infrastructure associated with the rule. Next slide, please. So what are the main pillars of remote ID? It's more than just a rule. There will be the operating and production requirements in the United States regulatory framework. This will become Part 89. But there will also be the industry standards that allow us to become the means of compliance for the rule. And we believe that the ASTM standard is probably the first one that will be likely to be a means of compliance to the requirements in Part 89. But you also need that remote identification network support. So it's quite a job to keep all three of these in sync and moving forward simultaneously. We're glad we're in a position that we've gone through our public commenting period. We received over 53,000 comments. That's almost a record in the FAA, but probably 10 times as many comments as we get for any other rule. I can characterize the comments by saying each and every part of the rule had a comment both for it and against it. So we had a lot to pour through, but we finished that, and we're actually finishing our final policy changes to the rule and starting into the review process. So we're really keeping pace. Next slide, please. So what does all of this mean for unmanned traffic management? I always like to start describing unmanned traffic management with saying it is not a box, it is not a single system. It is an ecosystem and a suite of capabilities. And we recently released our UTM 2.0 concept of operations. We made a couple of very large shifts in it. One, we recognized in talking about UTM 1.0 that the community was getting very confused and thought it was primarily just an air traffic services or air navigation service provider set of capabilities. And so we wanted to clarify in 2.0, what is the role of the regulator in UTM? So we've done that, and it's around describing the performance approvals and how those would work. And we still need to do some additional work based on feedback on everyone understanding those performance approvals. But if you think about it in light of the way legacy aviation uses required navigation performance or required communication performance, and that those requirements differ from in oceanic flight than, say, approach or departure in an airport, you can conceptualize where we're headed with the performance approvals and encoding those in regulation. The other thing we did is we recognized that UTM was, while we were saying it was a suite of capabilities, that we really hadn't done a good job of taking credit for the capabilities we already had out there. So for example, registration, we brought that under the umbrella of UTM. And we also brought our low altitude authorization and notification capability, or our airspace authorization tool, under that same umbrella. So we're seeing a far more robust UTM ecosystem evolve for us. The next version that we will work on, and we're starting to work on now, we're going to get much more industry involvement. We're going to use NASA to help guide those meetings, and because NASA can bring people, industry in under their authorities, we will be opening up more of the conversation to defining UTM to industry. We will also be putting more emphasis on security. Next slide, please. And that means I get to send it over to Natale. Back to you, Barbara.
Thank you, Jay, for this introduction and a clear overview of the approach from the United States. Now we're going to see the perspective from Europe. And we have Natale Di Rubo, who is the drone project manager at the European Aviation Safety Agency. He coordinates the activity related to the drone operation in the open and the specific category. Natale will provide you European perspective of the regulation for remote identification. Please, Natale, the floor is yours. Again, I think we lost the connection from Natale. So maybe what we can do is move to the next speaker, and then when Natale is back, we're going to come back to, yeah. So apologies for that. So we're going to move now to the connectivity parts, and we're going to have our first speakers, which is Eric Ringer. He is the Director of Aviation Technology at Skyward, which is a Verizon company. Eric is also the co-founder of, and he leads the product and engineering teams developing 4G and 5G solution for the aviation. And not only can provide us the perspective from the connectivity side, but also from a drone company which utilizes this connectivity. So please, Eric, can you share your experience from the United States?
Yes, thanks, Barbara. And welcome to everybody online. I appreciate you all tuning in. This is a pretty big milestone for me coming through the years of the drone industry. When I started Skyward with my team of co-founders, it was illegal to fly drones commercially in the United States. And that was back in 2012. So for us to be here, having worked with Fortune 200 companies, consulting with drones in their supply chain, helping energy and utility companies deploy drones on a wide scale to inspect their infrastructure, and to work with the FAA now on bringing compliance for remote ID to fruition, and working on universal traffic management. It's not just having new traffic management paradigms for drones, but we like to say universal traffic management, so that we're concerned with this system of systems that is inclusive of all modes of air traffic, whether that's crewed, traditional aviation, or drones. Next slide, please. So to help usher in a lot of that work, we are working with the FAA. We're a member of the Remote ID cohort. Jay talked about the means of compliance in the UAS service suppliers, USSs. Through this Remote ID cohort, we are working with the FAA to basically generate the first means of compliance. We feel good about the ASTM standard. And in fact, we helped demonstrate the effectiveness of USSs talking together, which is the essence of the ASTM standard, about a year ago with partners like Wing. So we got to fly in common airspace and show what you see in the middle of the screen there, live flights on one dashboard. Those flights were transmitted over the internet using cellular. We had a few different methods that we used, but what was exciting for us was to be able to fly a drone with direct cellular connectivity on the drone itself and be able to transmit that information into a common system for others to be able to access. And then others who were demonstrating technology there as well were transmitting their remote ID information directly from the tablet. So there are a couple of different ways that we had drones connected over the network, all collaboratively using the airspace. And that collaboration is a really key principle in aviation that I want to call out right now, and I'll echo again here in a few minutes. We also view remote ID and connectivity on drones in particular as a gateway to drone operations of the future. A lot of the ways that drones are deployed today is one pilot flying one drone within line of sight. But to really get to the high return on investment use cases that a lot of enterprises are seeking, it takes getting to fly beyond visual line of sight on a regular basis, as well as one pilot eventually getting to oversee multiple drones at once. Remote ID, being able to identify the users of the airspace cooperatively, is a key foundational element for being able to get to those drone operations of the future. Next slide, please. So speaking to the cellular side of things, Skyward is a part of Verizon. Skyward does fleet and operations management for drones. So we enable enterprises to be able to fly drones, use drones effectively and safely in their organizations. And then we also work with our network colleagues at Verizon to be able to advance use cases for drones using cellular. A lot of you on the call probably know this, but cellular in the air is a little bit different than cellular on the ground. The biggest reason why is when you get above the building line and above the tree line, the drone can see many different towers. That's both good from having options for what to connect to, but it is also challenging in the interference that's created. And we have a special drone service plan that allows us to specifically develop technologies that can serve those drones. It also helps us make sure that drones that are connected over our network are adhering to, at least in the US, FCC guidelines or regulations prohibiting the use of band 5 for airborne devices. The cellular industry has also addressed some ways that we can enhance the support of airborne devices through 3GPP and Release 15. So there are some optional elements that have been identified that can enhance the way that we support airborne devices. But our vision is to establish an ecosystem where drone operators can fly farther. And so when you get beyond that line of sight of the pilot, you get beyond that line of sight of that local control link, that unlicensed inspection that's typically used on drones today. And when you get beyond that line of sight, you need to be able to communicate with the drone still. And the commercial cellular networks that exist today are really good means for doing that. And it allows us to advance the control and the identification, remote identification of drones to almost no matter where they are, without having to build out specialized networks just for those drones. Next slide, please. We have also been building this out, not just for drones through our live flights feature in Skyward, but we've been prototyping it with other types of aircraft. So this is a screenshot from an experiment, a prototype that we did a proof of concept with a customer of ours in the Southeast. They're Southeast of the United States. They are a energy utility company, and we put in airborne IoT gateway into a helicopter, and we were able to add the helicopter into this collaborative system of remote identification. So it's not it's remotely identifying the vehicle and showing it in the same live flights view as Skyward. It's not necessarily hooked into the FAA remote ID system because that has not been built yet. And remote ID in those terms is for UAS. But what we're trying to demonstrate is the power of being able to see both crewed aviation and drone aviation in one place. That enhances the safety of both operators, both the pilot in the cockpit of that helicopter, as well as the operator of those drones. So this is just us showing the concept and the promise of cellular connectivity for aviation in the low altitude airspace. Next slide, please. And while that's just the beginning, this shows kind of the future that we think is possible through adding cellular connectivity into the aviation ecosystem. All those red dots are showing something being connected over the network. Again, the key tenet is collaboration. To be able to identify a cooperative participant in the airspace is important for all the other functions that come along with traffic management, from airspace access to detect and avoid in a more automated fashion on the drone itself. So it's pretty powerful. There's a lot that we can do with 4G LTE today, and there's a lot that we're going to be able to do with 5G as those networks get built out to greater and greater maturity. A lot of what we're talking about with remote ID is perfect within the 4G LTE environment. It's well suited in that environment where we are using lower spectrum, lower band spectrum, and able to connect to a wide variety of devices. But this is just a view into the ecosystem that we can imagine seeing as we get to more and more advanced use cases. Again, changing that paradigm for operations from one pilot flying one drone to eventually getting to where one pilot can oversee many different drones. Thank you all.
Thank you, Eric, for these presentations. It was very interesting to see the perspective and the vision that you have for the connectivity and how it helps to create connected aviation for manned and unmanned aircraft at low altitude. Now, I would like actually to go back to Natale to see if now we have a better connections. Apologies for the zapping. And I also want to remind you that we had the poll still open. So we will close now the first poll. So we hope that you have provided your input, and we will open also another poll. But please, Natale, can you now try to speak and see if we have a better connection?
Good afternoon from Cologne. Sorry for the technical issue. I hope that now you can hear me better. The approach we are getting here in EASA and in Europe is very similar to what Jay was described. The direct remote identification, also the network remote identification, will be essential elements to address safety risk, but also privacy and security. So as you may be aware, in Europe last year, we published a regulation that classified the operation in three big categories: the open, specific, and certified. These three categories are derived from those that in JARUS was called ABC. So open are the very low risk operation for which an operator is not required to ask for an authorization before doing the operation. The specific category are increased risk, where the operator is required to carry out risk assessment and then ask for authorization, while the certified category are those that instead will be similar more to the manned aviation, so the highest risk. The regulation that we publish at this moment is dealing more with open and specific. And one of the essential elements that we included are technical requirements for drone, where also the direct remote identification is one of it. In Europe, we have the possibility to use a process that is very common, that is those from the CE marking, that verifies that all products that are put on the market comply with some requirements, and it's called CE mark. For example, all systems that you can buy on the shelf, like this mouse, for example, you can see that on it there will be a label CE marking, showing that it comply with the requirements that are defined for this kind of product. So also for drones that are used in the open category, we are using the same system, and the regulation 2019-945 list these requirements and include the essential requirements of the direct remote identification. So this means that all drones in the open category needs to have this kind of system, unless they are privately built, and this allow the drone to broadcast a number of information that are listed in the regulation, including the identification of the operator, the position of the drone, and the position of the pilot or the takeoff point. All this data can be detected by each citizen through a smartphone, or more importantly, by the enforcement authority. And only the enforcement authority will have the possibility to access to the database where they can pair the information related to the operator registration number with the real identity of the operator. And this is in order to ensure the privacy of the operator. So the direct remote identification is the way here we are protecting mostly the privacy and the security for those operations that will be mostly in visual line of sight. When in the second phase, in the future, we will have a BVLOS operation, so this will fit more in the specific category. So the specific category, as I told you, is as those operations for which a risk assessment is required and where an authorization is needed. So in this case, you can go to the next slide, please. We will require a network identification system. And in Europe, we will deploy the U-Space, that is the equivalent of the UTM that we have in the United States, where the drone will be required to have a connection to the network and dialogue with the U-Space service provider and to the authority in order to receive a number of services. And one of the essential services will be the share of information for the remote identification in order to identify if a drone is legally flying in an airspace, and then also to give all sort of authorization is needed. Also, the requirements for the remote identification are written in the regulation 945. As a matter of fact, in the latest amendment that we published at the beginning of this year, we included so as I told you, a mandatory requirements for direct remote identification for the open category, but we included a optional requirements for the network remote identification in the open category, while instead for the specific category, we don't specify which type of identification is mandatory. The important is that the drone will have one of the two, either network or remote. But the essential elements are that whenever someone wants to fly in an area where the use space is deployed, then the network remote identification will be mandatory. In addition, member states may identify some areas where the remote identification is not required. So let's say areas where the risk is considered very low in terms of safety, privacy, and security, such that you can fly also without remote identification. But in general, this is one of the essential elements that is at the base of our regulation in order to protect all risk related to drone. So with this, I conclude my presentation, and I give you back the floor, Barbara.
Thank you, Natale. So thank you very much for this perspective from the European regulators. And now we go back to the connectivity, and we will see a next and last speaker, which is looking at the perspective of the mobile operator from Europe. So welcome Eric Murray, Principal Engineer of Vodafone Group Technology Network Architecture. Eric is responsible for identifying and developing new technology and innovation, which also includes the drones from several aspects. So please, Eric, over to you.
Okay, thank you, Barbara. So you can see from my title slide in my presentation where this is going. But if you could just contain your excitement for the moment, I'm not going to cut to the chase just yet. So Joe, if you could move to the next slide, I'll just give you a bit of background as to why this method of authentication is such a good idea. So if you could move to the next slide, Joe, thank you. So a quick review of the regulations, the EU regulations that are coming into effect this year. So there's two mechanisms defined for remote identification of drones. There's the direct remote identification, which is essentially the device to device, and there's the network remote identification, which is device to device, but through a network. And so I show that in the picture there, and you can see there we're anticipating the day when radios are built into the headgear of law enforcement officers. So when these regulations were put to consultation, Vodafone and the GSMA worked to ensure that they were written in a technology neutral way. And the reason for that was for both schemes, there are cellular technologies that can satisfy those requirements. So for the direct remote identification, there is a cellular device to device or D2D technology that's been around for some time now. That's not really gained traction until recently because it is being used for vehicle to vehicle use cases. So it's maturing quickly, and we see in the future that technology could have a role for the direct remote identification, and that would have advantages over the short range technologies such as Wi-Fi and Bluetooth. Now, I'm not going to mention that again. I'm going to move to the network remote identification because here clearly cellular is the obvious network to support this. But if it just worked as we operate cellular networks at the moment, then the application data would be transparent to us. All we would do would be transporting it between the drone and the law enforcement or whatever service requires the data. But if you think about it in a bit more detail, how is that data actually transported? Is it peer-to-peer? Well, it's not peer-to-peer. In fact, there's a server in the middle. So the drone is not communicating directly with the end device in the network case. It's connecting through a server, and that server we think will eventually evolve to use space. And so we've been looking at when the drone is connected to use space, how we can use the cellular network to enhance that use case. So if you just move to the next slide, please, Joe. Next slide, please. Okay, here we go. Right, so quick review of how we currently authenticate cellular devices. So our primary identifier is actually the IMSI, which is the International Mobile Subscriber Identity. That's stored in the SIM, and that identifies the subscriber, the account owner, the person who pays the bills. And that's a very secure mechanism. It's been around since the days of GSM, so that's, 30 years now. And we use that identifier for two purposes: internally, because that's how we do the billing, the quota enforcement if you have a certain data allowance, for example. But we also use that to look up other identities that the subscriber may have. And the obvious one there is what we call the MS-ISDN, or most people would call the phone number. So the phone number is not stored in the SIM, that's stored in our network. And so once we have authenticated the IMSI, we then know the phone number to use. We can know the identity of the device. So Barbara mentioned the IMEI at the start, but that's not as secure. So we tend not to use that so much in our network for the moment. I know there are proposals to make that more secure, but for the moment we are basing our authentication around the IMSI. Now, once we know the IMSI, we then can use that to identify the call originator to the destination. Now, how we do that depends on the service. So for the circuit switch services, which are primarily voice and SMS, then it's the MS ISDN is forwarded. So when you receive a text message, you get the caller's identity in terms of their phone number, and you know who that call is from. But for packet switch services, there's more of an assumption of privacy. So we don't provide a unique identifier at the moment. We provide an IP address, but that's netted through a shared pool, and that pool can be surprisingly small. So, for example, Vodafone UK, the total number of addresses in the pool is less than 3,000. So it's shared, it's dynamically allocated, and so you can't identify the call originator just from that at the moment. If you record the IP address, the port, and the time it was assigned, and you come to us with that information and the court order, then we can tell you what device was doing that communication. But that's retrospective. That wouldn't work for real time. And here we're talking about automation. So for the moment, authentication between the client and the server is done transparently to our network, and that would use mechanisms such as username and password. So if you had an app on your phone, you would put a separate username and password, and that's completely transparent to the network. And that would work in this case, but there are some benefits that the cellular network can provide. And if you just go to the next slide, please, Joe, I can discuss the benefits. So why might we want a change? And the reason is that there may be some drones who are not honest and would try to spoof the use space. So why would they want to do that? Well, if you think about it, imagine that you were wanting to rob a bank and you wanted to hide the identity of your getaway car. Well, you might say, okay, I'll remove the number plates. But by doing that, you would draw attention to yourself because cars are meant to have number plates. So if you remove the identity, then it draws attention to yourself. So what you really want to do, if you're being dishonest, is to try and fool the system as long as possible until you achieve whatever illegal activity that you plan to do. So a better strategy is to steal somebody else's number plate or to clone it. So to avoid that situation, we can imagine the use space system would like to confirm some details. We'd like a second opinion on the identity of the drone, to check that it really is a drone, to check it's being operated by who it says it is, to check where it says it is, and to be sure it's connected and will remain connected by cellular through the flight. And the cellular network knows all this, and we know this independently of the drone. Now, clearly, it depends on the SIM in the drone. But if that SIM is registered as a drone SIM, then as part of that registration, we would get the operator's identity. Using network-based geolocation techniques such as Vodafone's radio positioning system, then we can independently estimate where we think the drone is, independent of any GPS feed from the drone itself. And we can use our propagation prediction tools and indeed any measurements that we have to confirm that the drone will have adequate cellular coverage for its proposed flight. Now we get to the interesting bit. So if we can move to the next slide, please, Joe. How do we provide these additional parameters to use space independently of the drone? And so a proposal is to use an API gateway. Now, I don't have time to tell you in detail what an API gateway is, if you don't know, but to summarize, you can think of an API as being just as a language that's used by clients to talk to servers, and it's designed for transactions. So the client is requesting something, and then using the API, the gateway can respond either with the information that's been requested or a confirmation that the particular action has been done. And the purpose of the gateway is also to inspect the request and then to decide how best to fulfill it. And quite often it would then pass that request on to another system, in this case the use space, to get the use space to fulfill it. But because we're using APIs, we can in fact append additional information to that request. So in this case, we could append who we think the drone is, its identity, and where we think it is, another information. And then the use space can cross-reference that with the information that the drone itself sends transparently to our network. So that's much more secure authentication. As the flight goes on, the use space, we'd have another API that the use space could use to check, if it wants to check where the drone is now, it can do that. If it wants to check where the drone still has coverage, or perhaps there's a change of flight plan, it can do that. And if it has to send flight plan updates or say no-fly zone updates to the drone, it can do that back through the API gateway. So we can see the advantage to use space, but this scheme also has advantages to the drone. Because as far as it's concerned, the API gateway is the use space. It doesn't have to understand what's happening behind that. So if the use space evolves, if there's a change in use space provider, or if there's multiple use space providers, or the use space is regional, that can all be handled by the API gateway. You don't have to change what the drone does. And in fact, the API gateway is responsible for authenticating use space. So the security, as far as the drone is concerned, is handled by the API gateway. So if we just move to the last slide, please, Joe. So this is just a summary. So I mentioned for direct remote identification, we can look forward in the future to using cellular technologies to device to device. But I think before that, we'll start to see drones connected to use space. There, the cellular network can provide secure authentication and indeed additional information, such as the drone's location or the predicted coverage quality, can provide that through an API gateway, and that acts like two-factor authentication, where we have a second factor provided by Vodafone independent of the drone. And this is part of a larger program that Vodafone have to expose network capabilities through APIs. So we can start to see this technique being used in a large number of use cases, not just for supporting drones. Okay, thank you very much. Back to you, Barbara.
Thank you, Eric, for giving this overview of the services that the mobile operator can offer. So now I would like to close all the polls and maybe invite all the speakers to join for the panel session where we will answer your question. If you didn't send yet your questions, please do it now. We still have time. Before we go to the first question, I would like to give an overview of the answer on the polls. So the first poll was related to the regulations, and we asked how are you familiar and if you're already planning or been involved in either the solutions, the broadcast or the network solution. So I have to say that the majority of the speakers says that no, they're not aware of regulation in their country, and they would like to know more. But the second, it's also coming quite strong that they're already preparing to use and support both the broadcast and the network-based solution. So that is just for when we answer your question, we have in mind who our audience is. And from the perspective of who they are, as expected, the majority they're coming from different stakeholders. So they're not very familiar with the mobile network. Second stronger is instead they are mobile operators, so they're quite familiar, so they know the network. So we are going to keep in mind these two responses, which will help us to give the appropriate answer to all of you. Maybe let's start with one very generic question, and it is about how cellular technology enabled to have scalable operations. So maybe I'm going to start with you, Jay, first, if you don't mind.
Absolutely. Well, I think we believe that cellular technology is essential to a scalable and economically viable system of drone operations in the United States. And also answering one of the other questions, I've been busy in the background typing away and multitasking. I think Eric Ringer did a great job of describing the ways that cellular are supporting UAS here in the United States, and in particular the work that they're doing with Wing in Christiansburg, Virginia, and how they're supporting that operation and the command and control associated with that. And seeing the results coming out of it, I think it's increasing our confidence in the role that cellular can play in this space. There really is no other alternative technology that we know of right now that would support the kind of scale that we're looking at. And we expect that the UAS industry will be tied to mobile telephony, and as it advances, the industry will advance as well. So absolutely essential to the industry. And I think the next challenge for both regulators and for the mobile telephony industry is to start defining the performance that through industry consensus standards that we all need and that we all need to rely on, so that as operations start expanding and becoming more complex and scaling up, we know that we can meet that demand safely.
Thank you, Jay. Yes, I want to
chime in here.
Also to you.
Yeah, thanks,
Yes,
Barbara.
thanks.
And I want to clarify, Jay, when I was talking about a demonstration with Wing, I was referring to the inter-USS demo we did last September. But I think the point is the same. There's a lot of great ways that drone operators are starting to use cellular for more and more advanced applications. There's also a lot to be said for the work that we're doing as both an aviation and a cellular company through GSMA and through GUTMA in the aerial connectivity joint activity, as we work to bring those two industries together to work through how we define the levels of service that need to be provided to support those advanced drone operations, how we translate those into standards and other standards organizations that can be referenceable by industry and regulators alike. And then how we not only define those levels of service, but how as an industry, a cellular industry, we're able to translate those into profiles for service. And that's applicable across 4G and 5G. If we know the target levels that we need to hit for the different applications, be that critical communication for things like remote ID and command and control, through to business applications like live video streaming for remote infrastructure inspections, then we're better able to know what we need to do configuration-wise with the network to be able to deliver those services. And when I say configuration-wise, I'm talking about things like APNs, that kind of stuff. I'm not actually talking about physical infrastructure changes. A lot of the connectivity, the coverage that we see in the air, coverage footprint is similar to what we see on the ground. More about how we deliver the quality of service to the vehicles. And there was a question in here about reducing neighbor cell site interference. That's one of the things that we're testing different methods of doing that. But by and large, they don't require infrastructure changes, which is pretty exciting. So yeah, more to come there.
Thank you, Eric. Maybe one question for you, Natalia. So we've been asked, how does it work, the relation that you have now in place for the legacy drones? Are these drones going to not being able to have remote identification? how they will be allowed to operate after the applicability of the regulations. Yeah, can you give some insights on this?
We will have a ability to develop then to the drone when they are not developed with this system compliant since the first design. So we already identify within the regulation a model that can be included in the drone such that at the end they can be compliant. So we would like to make sure that when even if the regulation will be applicable since the beginning of next year, then this is facilitated for those drones that are not equipped with it.
Thank you. So I was looking, now there's quite a lot of questions. So maybe let's go to one question for you, Eric Mare, from the Vodafone perspective is how do you see a cellular network that are going to be able to determine the location of the drones accurately as a GPS could be compromised? Can you explain a little bit more how that could be achieved?
Okay, so cellular devices are always sending telemetry to our networks, and primarily they're sending what neighboring cells they can hear and how loudly they can hear them. So if we know where those cells are, we can estimate the drone location, and that's independent of any GPS feed from the drone. Now, it won't be as accurate as GPS, but nonetheless, if the drone is trying to spoof its GPS location and pretend it's one place when it's actually somewhere else, that won't fool the radio measurements. We will still have a relatively accurate location for that. And we've been doing a lot of trials on that over the last few years.
Thank you on that. So I see that we are almost to the closing time. So I want to take a question that I see it's coming up in a different way or format. And it's a little bit for both of you, is actually to understand, the question was mainly addressed to the FAA, but I think it's for everybody, is how do you see the collaboration with the mobile operator from the regulation for the remote identification, how it is collaboration happening with the mobile operator? So if I can close with a sentence from all of you that you can describe how this is possible. Maybe start again with Jay.
So we keep a very active conversation with the mobile network operators in the United States. And we welcome partnerships with them, demonstrating things like, as Mr. Ringer mentioned. And so really the sentence is, we're engaged with our mobile network providers in the United States, and will continue to be engaged as we explore the uses of this technology in support of drone operations.
And Natalia, maybe from the European perspective, how actually do you see the regulator collaborating with the mobile industry?
Yeah, we had in the past several meetings with them, and we think that we to do with them. And we also have a European standardization team that where also GSMA is part. So we have a lot of expectation, yeah, because we think that also for us this is one of the most promising technology. So we just need to continue to have the dialogue like we are having so far. I think that we are very happy about how this is going on.
Now I go, thank you, Natalia. Now I go to the two Erics. Let's start maybe first with Eric Murray.
So clearly we believe cellular technology is the right technology to use for beyond visual line of sight drone use cases. This is not for every drone, but there are some use cases where it really does make sense. Now, it could be that we're just used to transport the data, and that's transparent to a network, and that would work, but that's not best using the cellular network. So we have, over the past few years, tried to demonstrate the benefits of using the cellular network more intelligently And in terms of use space, what we would then do is work with regulators and use space providers through this API technique to ensure that the use space was willing to accept that as a method of authenticating and communicating with the drone.
Thank you for that. And then the closing remark from you, Erik Ringer. How do you see the collaboration happening?
Yeah, for collaborating with regulators from MNOs, we see it kind of in two different avenues. One is direct Verizon, Skyward to regulator. We do that through replying to RFIs. We do that through participation in the remote ID cohort with another MVNO or MNO, as well as other industry members that the FAA has chosen for that cohort. And then we also have more one-on-one projects going on. And then we also think it's extremely important that we engage with the regulator from the industry perspective as well. Because while we are a provider of cellular service, it's the cellular technology as a whole. I think a lot of what Eric Murray was referring to, it's cellular technology as a whole that has a chance to really economically provide, I think, some growth opportunity for the UAS space. And so we do that through industry organizations and standards bodies. I'll point back to, again, the Aerial Connectivity Joint Activity, where we're bringing aviation and cellular together from an industry standpoint, so that there's not too much of one voice shining out, but that we are looking at the technology and what the technology can provide to the use cases that are required.
Thank you, Erik. So now to close, I would like to thank you all our speakers for the great input, but also I would like to thank all the attendees. I just want to remind you, so we will have one closing slide for you where you will see the information. Again, we were able to answer your question. We will do it after this event, so you will be contacted to provide the answer. And if you want to see the recording and the material, it will be available soon on our website. Also, if you have further questions, there is also an email address where you can post your questions, and it's quite easy. So it's com, and you will see what is drones@gsma.com. So thank you, everybody. And again, it was a pleasure for having this WebTalk. Thanks. Bye.